Hello, stat class. Today I'm going to go over section 5.3, the binomial distribution, and these pages are mostly coming from your workbook that starts on page 134. But I did send you an email about there's some extra pages. Sometimes the workbook's a little bit deficient, and we haven't since added them. We really need to add them to the workbook, and but until that happens, I've got these extra handouts here that you're going to want to have. And if they're not already added to the workbook, then they're set up in your modules for this next test 3. So I believe that's module 8, I believe. It's covering test 3 material, chapter 5 and 6. And so these are extra problems that I'm going to work on for this section 5.3. And then there's an extra sheet here also to work on. So you want to have those out because I'll be working on those with this video recording. Okay. All right. So first we're going to go over some vocabulary here. The binomial experiment is a probability experiment that satisfies these requirements. So they're mentioning how there must be a fixed number of trials, okay, and which we'll call n. Okay, and oftentimes when you read your problems, you want to look for keywords like how will you know what number to use for n for your number of trials? So usually they'll tell you because they'll tell you that there's a random amount. They'll use the word randomly. And that's how you'll know that's related to your trials by the usage of randomly. Um, and some examples trials would be like uh, the number of questions on a test, or the number of times a die is rolled. And you'll see that in the problems that we'll do today. These are some of the things that will come up in the description of the problems. Each trial can have only 2 outcomes. So you have what they call success or failure. The outcomes of each trial must be independent of each other. So that would look like this, right? And that would also be an example of mutually exclusive. So one event does not influence the other. And then we have that the probability of success must remain the same for each trial. And the probability, sometimes they'll give it to you. For example, they'll give it to you as a number out of so many. So like, for example, 1 out of 9. And then that would be written as 1/9. And then that can be 1 divided by 9. Okay, so that's 0.11 repeating. So let me instead use something that terminates. If something repeats like that, we don't want to round that off because we'll have round off error. So you would actually have to use the 1/9. But let me do something like 1. Yeah, that one repeats. Let me just say like 1 out of 5. right? 1 divided by 5 is 0.2. So let me use that as an example. Because if something terminates, then you can work with the decimal. If something repeats, then you don't want to round it off on your own, because then you have round off error. So that's why I'd rather use 1 out of 5 as an example here. Or you can, on these examples, or for probabilities, you could be given a percentage. So like, like 35%, that would be 0.35. That terminates. Okay, so you'll notice that in the problems when we read them. Okay. Now, there's lots of notation to be familiar with, notation for the binomial distribution. So this, and I like how they have the symbol and then the description. So this is the symbol for the probability of success. This is the symbol for the probability of failure. So we mentioned that over here, 2 outcomes, success and failure. This is the numerical probability of success. They call that little p. Capital P stands for probability. So they use little p. And then the numerical probability of failure, 1 minus p. So this is important. I'm going to highlight that. I find that on tests, oftentimes people, even though I let students use their practice tests when they take their tests, I find that students oftentimes forget to include this formula by their problem related to that. And then they get stuck on the test because they don't remember what was the value of Q. They know they're supposed to use Q in the formula, but they can't remember what that value is. So it's 1 minus the value of P. So don't forget to include that on your test review for that related problem. N is the number of trials. Capital X is the number of successes in trials. And you want to pay attention to capital X. Notice how it starts with 0, 0, 1, all the way to a certain value, which they're calling in. So it does start with 0, so that's important to note. X begins with 0. And then we're going to use, we use our, it says in a binomial experiment, the probability of exactly X successes in trials is this, but we're going to use the TI-84. So we use the TI-84. So back in the day when I was in school, we did everything by hand. So we had to do this by hand. I recently observed a dual credit. When I observed the dual credit teachers, like there's some that are associated with Wagner High School, for example, and also Brackenridge High School. So like, for example, at Wagner, their instructor for dual credit does this by hand. The students do this by hand, whereas the instructor at the Brackenridge High School, they use the TI-84, which is what we use. The faculty at St. Philip's use the TI-84. Okay. So when you look at your videos for Connect Math, it's good for you to see the videos, even though they are doing them by hand. But just know that you don't have to. You're gonna use a calculator. But it's good for you to see the idea what they're calculating by hand. So by hand using the calculator probability, they'll show you that oftentimes in some of the Connect Math videos. And then they have using the built-in binomial function. And I'm going to give you we're going to do the examples using the TI-84, okay? So I'm not going to jot anything down for that. Now, I will say that you want to have this sheet handy. This sheet we use for test 2. You needed the deck of cards and you needed the sample space here for rolling 2 dice. And when we take the final, you can have the sheet out as well. now we're going to use this same sheet. This will be used for quiz number 3. And if you haven't already changed this, I think in one of the videos I asked you to change this to semicolons. So if you haven't done that, you can fix them here. These should be semicolons, but this we'll use for quiz 3. And then this part, we're going to use this, mostly this right here is part of the binomial. So mostly this is section 5.3 right here. See the binomial distribution. So this is section 5.3, and we're going to use this vocabulary. And then this is also helpful for quiz 3, and it's related to your hypothesis testing. This is also vocabulary. Okay. So have that sheet handy because we will make use of those. Okay, and then let's see. What I will say about page 136, I'm going to look, we have a couple problems on 135 to do, but 136 doesn't have any problems on it, but it also has its own table and list of formulas. And this should be similar to this. So it has, like, for example, let's see, if I look at the word exactly, probability of exactly X, you can see that here. And then symbols, it says probability of X equals a given number. So you can see how I have that here. And then it does have the command. So see your command binomial PDF, but this one has a little bit more in PX. And this is how we'll type this in the calculator. We'll need the trials and then the probability, the number of successes in that trial X. We'll fill those in the calculator. And then this is the calculator command that we use. Sometimes, well, we always use second vars. So let me show you where that's at. On your calculator, here's the second button and here's the vars. So we always make use of second vars. You can see that here. But then sometimes they say option A or option B. So they have PDFs and CDFs. So and so I'm going to show you that in a little bit, because sometimes we'll be making use of the alpha math key. So you see this alpha key here, and then the math key because it's got an option A. And that's what they mean here by option A, but they didn't put alpha and math. They kind of left some things out here. And then alpha apps B. So alpha apps B, because see there's a B there. So let's see, they just put option B. So they didn't put the alpha in there. Okay. And then sometimes you have the idea of a complement. Remember complements from chapter 4, test 2, 1 minus. So this is the idea of a complement when you do 1 minus. Okay, so this, you'll see here on the sheet that I have, see some of these are complements. See 1 minus, 1 minus. And you'll also notice here, look how there's also some extra subtraction. See how this needs an x minus 1, or this is just x. See how this needs an x minus 1? So this depends on your vocabulary. So whatever your vocabulary is, you will have to be ready to subtract on these two right here. That's important. Okay, so you have to pay attention to that. Otherwise, if you don't follow then the direction that you don't follow directions, you don't follow those instructions, and your math won't come out correct. And then old school also we've used tables before. So I also have done a lot of experience in the past in school using tables, but we get to use the calculator. So we will do one problem that has a table, and in your Connect Math, they might also pull up the table as well, but you can always do it on your calculator and get the same answer. So I'll show you one example with a table since they've got that in the workbook. They have one problem where they show you that. Okay. Um, then I want you to take out a clean sheet of paper, and I'm going to summarize the three main commands that we're going to use. So take out a clean sheet of paper, and I'm going to summarize this before we actually start a problem. Okay, so the simplest example of these binomial distributions will be the usage of exactly. So for the binomial PDF, a TI-84 command makes use of x equals exactly. Okay, so the command reads binomial PDF in PX. So an example would say, let's say they're making use of x equals exactly 4. They would have to use that in their vocabulary, exactly 4. So what that means is you're trying to find probability at 4. Find P of 4. Okay. And on the calculator, you would be using you would be making use of the second button, the vars button, and on top it has DISTR, distir. That's for distribution. So your distribution. And then you're going to make use of alpha and math. And there's your that option A. Okay. And what will pop up, and we're going to do problems. So you'll see when we do this, these will be the first ones that we do. You'll get a pop up for trials and probability and X value. And then this pace would come up. Okay. Okay, then we have for the binomial CDF. So here we'll do some other problems where they won't use the keyword. So this exactly is a keyword. Exactly is a keyword. Okay. Or vocabulary word. Okay, so you see that here. Exactly is your vocabulary binomial in PX. Probably X is equal to a given number. So probably a 4. Okay. Well, for the binomial CDF, okay, this is use for x equals 0, remember? 1, 2, 3, and so on and so on. And I think the paper used n on the paper. Sometimes I put all the way to x, but I think they used n. And note that this begins with 0. Okay, so an example would be, suppose we have that x is less than 7. So x is less than 7. Okay, so this means that our x is equal to 0, 1, 2, 3, 4, 5, and 6. Didn't say less than or equal to 7, just said less than 7. And then this means that we want to find probability of 0 plus probability of 2 plus probability of 3 plus all the way down to probability of 6. That's what that would mean. And so we use Binomial Cdf, which has NP, in this case, x minus 1. So remember, x was less than 7. So this is 7 minus 1. And 7 minus 1 is 6. So NP 7 minus 1, which is 6. Okay. Okay, now when I look at that on the sheet, and the keyword was less than 7. So you see, I'm getting that from here. See, right here, less than, right? Less than. So that's where I'm getting that from. Binomial CDF NPX minus 1. See, that's where I got this from. So I'm doing 7 minus 1. And you have here probably x is less than the given number. Okay. So that means I want to say find probability that x is less than that given number, which is 7. And that would equal these summations, p of 0 plus p of 2 plus p of 3 and so on. Okay. So where this one over here, find p of 4. So for the exactly, so I can actually come back and do this. Find p parenthesis x equals 4 equals probably a 4. Okay, only 4, exactly 4. Where this one you're finding from p of 0 summations all the way, counting all these probabilities all the way to 6, because it said less than 7. And that formula needs 7 minus 1. 7 minus 1 is 6. So this is successes from 0 through 6. See, 0 all the way to 6. Okay. And we would use second vars, like they all use second vars here to stir. But then you go to alpha, and then you want apps. So they all use alpha, but one uses math and one uses apps, because one uses option A, and the other one uses option B. Okay. And but other than that, this will look the same as before. See, you're still going to have to put in your trials, which is your n value. You still have to list your probability. You still have to list your x value. And here your x value will be 6 for this example, because it's 7 minus 1. 7 minus 1 is 6. So this is your x value. Okay. Because you see in the formula, it's yeah, NP x minus 1. That's how it defines it. So x is 6. Okay. And let's see. Here on this one, the x value was just 4. Exactly 4. So for this one, it was 4. Okay. All right. And then it has a pace also. Okay. Okay, and then the last scenario. So these problems that we're going to work on. They're going to be like, it could be one of these 3 types. Okay, you're narrowed down to these 3 types of problems in 5.3. So the other one uses the complement idea. Okay, so we have 1 minus binomial CDF NP x minus 1, or it could be 1 minus binomial CDF in PX. And this is depending on the vocabulary. So if I show you that here, that the complements, see, 1 minus binomial in PX, this is limited to this vocabulary here, greater than, more than. And see this one, 1 minus binomial CDF in PX minus 1. This is limited to this vocabulary here. Okay. So this means x is greater than or equal to a number. This means x is just greater than a number. Okay. All right. So those are the ideas for complement idea. And suppose we have that x is greater than 7, and we have 10 trials. Okay, greater than 7. Okay, so then that would be your n. So here n would be 10, and here greater than 7, so that would be 8, 9, and then 10. It would go up to 10 because there's 10 trials. Okay, so that means that we want to find, and if I look at the vocabulary, greater than 7, right here, see, greater than. So probably x is greater than 7. So this would be probability of 8 plus probability of 9 plus probability of 10 is what that would equal then. Okay. And so the reason why like, in order to find that on the calculators, we have to use the complement idea is how we figure that. And that's because, you know, for these probability distributions, and these just happen to be binomial distributions, but for in general the probability distributions, even like from 5.1, you learn that there's some is equal to 1. So here what we have, 1 is equal to probability of 0 plus probability of 2 plus probability of 3 plus probability of 4 plus dot 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 all the way to probability of 7 plus probability of 8 plus probability of 9 plus probability of 10, because there were 10 trials. Remember, n has to do with your trials, and there was 10 of them. So you have one, this, all these, when you add these up, have to equal exactly 1. Okay, these probabilities. And so what we have to do is we have to subtract probability of 0 through probability of 7. See, because we want to find this. We want to find 8, 9, and 10. So we need to subtract all of these. So like you're using a little bit of college algebra, right? These, you're going to have to subtract these. Okay, so that's where we get the complement idea. That means if you subtract these, you would have 1, and in an equation you balance it, and you'd use opposites. So you use opposites, you subtract, and you use opposites. So 1 take away p of 0, take away p of 1. I think I skipped 1, p of 0, p of 1. So I think I shouldn't skip that. So this is p of 1, should go in order. P of 2. I'll just put this as p of 3. So p of 3. So p of 1, p of 2, p of 3. So we're subtracting p of 0, p of 1, p of 2, all the way down to dot, 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 all the way down to p of 7. And then that's going to leave you with p of 8 plus p of 9 plus p of 10. Okay, so you're taking all these out, subtracting them, and they don't disappear. They come over here across the equal sign. So you have 1, take away p of 0, p of 1, p of 2, p of 3, take away p of 4, p of 5, take away p of 6, take away p of 7. And all you're left with is these 8, 9, 10. That's what you're trying to find. Okay, so that's where we get the idea of 1 minus binomial CDF. Remember, CDFs, very important, which begins with x equals 0 and p of 0. Okay, so I didn't put like 1 minus binomial. I didn't put PDF. PDF is exactly, 1 probability. This is CDF. It starts with 0. And we want to go 0 all the way, in this case, to 7, so that we're left with this. Okay, so that's this idea. That's the idea of the complement. So then in your calculator, this is important. You have to remember, sometimes students miss it because they forget this. You have to remember to type this in. So you have to insert first one takeaway. So you got to remember that. Don't forget. Don't forget to insert first 1 minus, and then you can do second vars. And then you want to use, okay, everybody uses alpha, but then then you're like, okay, is it the math option A or the apps option B? And so remember, the math option A is for PDFs. The apps option B is for CDF, and that's what you want. So you want apps B. Okay. All right. So that's the idea. That's what we're going to be using, one of these three types of formulas and using our calculator. And that's what we're doing. We're summing probabilities. Okay. All right. So let's look at page 135 where they have your first two examples. Let's see. Okay, here's your first problem. These are what these problems look like. Survey on doctor visits. So a survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. So here's your probability. 1 out of 5. So, your successes over your total, okay? So on the side, I'm going to put N equals P equals X equals. And you should notice this when you print your practice test and when you print your test template, you should notice these blanks here to fill. You want to fill those in. You don't want to leave those because those count as rubric points. Those are part of your showing your work here. And so for us, the probability is 1 out of 5. So successes 1 out of total 5. Successes over total. So 1 divided by 5 is 0.2. And when we put this in the calculator, I'll use the 0.2. And if 10 people are selected at random, okay, so that's another helpful. Remember the word we said random? Remember we said random tells you about your number of trials. So that's our N, 10. Okay, so 10 people. Okay, and they're randomly selected. That's your keyword. Find the probability that exactly 3. So this is your vocabulary. And your vocabulary, that's your keyword. Exactly 3. So if you remember that's this one, the easiest and the first one, exactly 3. And this is the formula command we're going to use, binomial npx. And here probably x is equal to the given number. So when we write this up here for x, this is just 3 exactly. It's just 3. If you want to just put 3, you can, but it's 3 exactly. And then here's your problem setup. Probability of x equals 3 equals, here's your command, binom pdf npx. And then you're going to do your substitutions. Binom pdf 10 for 10 people, p.2, and x is exactly 3. And what are you finding? You're finding just P of 3 is what you're finding. P of 3 only. So when you use your calculator, you're making use of, again, second vars, alpha, and then math, because math was that option A. And then let's see what that probability is, okay? So you get your calculator out. Okay, so you hit second, which is here, vars, which is here. Okay, and then we're gonna use a shortcut. So the shortcut is always alpha and then math option A. And you see it takes you to this. Okay, so then your trials, that was that's in, that's 10. So type 10, enter. Your probability is 0.2, so it's 0.2, which is just 0.2, enter. And then your x value was exactly 3, so just hit 3 and then hit enter. So you have 10, 2, and 3. 10.2 and 3. Enter, enter, and then enter. So you can double check that again. 10.2 and 3. That matches here. And then hit enter again. So lots of enters. And there's your probability. And then we're going to round that to the nearest thousands. Tens, hundreds, thousands. Then look at the number to the right. Is that 5 or more? Nope. So it's approximately 0.201. Okay. And if you want a percentage, if you want that in a percentage, you just do times 100% and times 100%. And if you round that to nearest tenths, that would give you about 20.1%. Okay. So I'm pretty sure Connect Math, I think they just, pretty sure they just ask you mostly for the decimals. I don't think they have you convert it to a percentage, but in case they do, just remember this idea from chapter 4 test, multiply by 100. Okay. But that's what your problems, those are kind of what your problems look like. So you're finding probabilities, and this is an example of this is an example that meets the requirements for the binomial distribution. So remember what they said about the binomial distribution. So the experiment, probably experiment satisfies the requirements. So fixed number of trials. Each trial can have only 2 outcomes. So success or failure, right? And then the outcomes of each trial must be independent of each other. The probability of success must remain the same for each trial. Okay, so that idea meets that. Okay, now here, where I make use of my formula sheet here, you saw your teacher make use of this. They have that, I think here also exactly X is a given number, binomial PDF, but they don't have NPX like mine does. Second vars and option A, but again, they don't say alpha and then math. So it's not perfect. It's similar, but it's not perfect. Okay, but that's where that's coming from. All right. Okay, here's another example. Survey on employment. A survey from Teenage Research Unlimited, this is from Northbrook, Illinois, found that 30% of teenage consumers receive their spending money from part-time jobs. Okay, so 30%, okay, of these teenagers. So that's your probability. And they receive their spending money from part-time jobs. Yeah, and that was me back in the day in high school. So I think think I've started working, I think since I was, 16, I think when I was started working at McDonald's. So I worked as a, behind the counter selling McDonald's there as a teenager. That's how I would make my extra spending money um, to buy things like for senior year, that kind of thing, saving up for that. So, so that's your probability. That would be 0.30 for your probability. So I'm going to put here n equals blank, p equals 30%, which is 0.30. You move the decimal 2 places to the left, which is just 0.3. So you move decimal 2 places to the left. Okay. All right. And then if 5 teenagers are selected at random, so there's your keyword, that random. That's your helping you with your number of trials. So 5. So n is equal to 5. 5 teenagers. They're randomly chosen. That's important. Okay, keyword randomly. So that's your 5. Find the probability that at least 3 of them will have a part-time job. Okay, so I'm going to highlight that. That's your vocabulary. At least 3. Okay, so this is your vocabulary. Okay, so what you should do is you should look for at least on your chart here. Okay, so look for at least. Here it is, see? At least. This is it. So you want to make use of this. So you want to set it up like this. Probably x is greater than or equal to a given number. And your given number is said, they said at least 3. So you're going to say probably x is greater than or equal to 3. And then you want the command 1 minus binomial CDF in px minus 1. Okay, then I'm going to start doing my substitutions. 1 minus binomial CDF. Okay, so n is 5. P is 0.3. And then your x minus 1. So it said greater than or equal to 3. So it's going to be 3 minus 1, which is 2. Okay. 3 minus 1, which is equal to 2. So 3 minus 1, which is equal to 2. I'm trying to squeeze this in. It's not letting me do that. Let me see. Okay, there. Can you read that better? So 1 minus binomial CDF. Okay, 1, 3. Okay. So what this means is this is going to equal 1. And what are we taking away? Remember, CDF starts from 0. So we're taking away P of 0. We're taking away P of 1. And we're taking away P of 2. Okay. So that's what we're taking away. P of 0, P of 1, and P of 2. Okay. And so then what does that mean? What are you finding? So what we're finding is what's left is P of 3 plus P of 4 plus P of 5. And we stop at 5 because there was a total of 5 teenagers. Okay. So what you're left with is P of 3, probably a 4, probably a 5. And that's what you're summing, 3, 4, and 5. Okay. All right. Now, what that means over here, see how I've left this blank? I still have to fill this in, what my X's are. My, like, how do they call that? The X's of success over here. So the number of successes in your end trials. Okay. So this is going to be 3, comma 4, comma 5. Okay. And also because see it did say greater than or equal to. See this underscore? Greater than or equal to 3. So you see it starts with 3, 4, and 5. And it stops at 5 because there was 5 trials, 5 teenagers, 5 trials. Okay. Okay, now when you use your calculator, you're going to use, okay, this is important. Don't forget, sometimes people make a mistake. You need to do 1 minus and then second vars, and then alpha, and then you want the apps. So you want the B, apps B. Okay. So when I typed in the calculator, turn this thing on. So don't forget, you have to do 1 minus. So 1 take away. Okay, then do this second vars alpha, which is right here in green. And then apps, it's, I don't know if you can see that now, it's purple. See right there? Apps B. See math A, apps B. So apps there. Okay, see how that pulls up? Okay, so then you want trials, and that's 5. Probability, it's 0.3. Okay, then you want X value. And okay, so right here, you see this command, see? Binomial CDF. See that? And you see this right here? Binomial CDF. So you see, we're typing this in. See, 5.3. And then this is, remember, 3 minus 1, which is equal to 2. That's why here you want to type in 2. And what that means is you're taking away from 0 to 2. You're taking that away. And when you do 1, see, we already did 1 minus on the calc. That's the first thing I typed, 1 minus. And you're taking this away. Then what are you left with? You're left with 3, 4, and 5. The probability sums for 3, 4, and 5. Okay. So this is important. This helps you with what you type in here. Okay. So then hit enter. Lots of enters, right? And then you round to nearest thousands. And then you look at the number to the right. Is that 5 or more? Nope. Okay, and then down here they have, they focus on the vocabulary, at least X successes, and then probably X squared equal to their number, 1 minus binomial CDF, 1 minus second bars option B, see, NPX minus 1. See that? Okay, all right. Okay, now let's go to page 137. Yeah, because 136 we already talked about. You know, they don't have any problems on there, but they're talking about the vocabulary and the chart there. Okay, there is one problem on there. No, not 136. We're gonna do 137, but not right now. But was there? There's one more problem somewhere. Let's see, where is it? Oh yeah, yeah, it is. It is at the top of 137. Yeah, I was thrown off. This, we're going to do this towards the end. This is also in chapter 5.3, but this is something a little bit different. They require these formulas here, so this is a little bit different. So we're still doing this first part of the 5.3 binomial distribution. So I need to, this is a problem I need to look at. Let's see. And then we're gonna do the extra ones I have. Okay, this says tossing coins. So a coin is tossed 3 times. Okay, so the coin is tossed 3 times. So this is your number of trials. And let's see if I had something on that to share with you. I think I said keywords are either randomly or like the number of questions on a test or the number of times a die is rolled. In this case, not rolled, but the number of times a coin is tossed. So that counts as that. So your N is 3. 3 tosses, 3 coin tosses. So these are trials, considered trials. Okay, now the probability, find the probability of getting, there's exactly 2 heads, okay? So here, you want to think of, to get your probability, it's the idea of successes over the total. So here they're saying they're interested in the heads, but the denominator could be heads or it could be tails. So that's why the probability here is 1/2. Heads over tails, heads or tails, so that's 2. And 1/2 is equal to 0.5, okay? And then the x is exactly 2. Okay, so first I'm going to do this on the calculator, and then I'm going to show you the table, because I think in Connect Math, I think they're in your program, I think there's a program where they want you to use the table, but I'm going to do it on the calculator first. Okay, so the keyword, I'm going to highlight the vocabulary, which is exactly. Okay, you see right here exactly. So probably if x equals a given number, which is 2. Okay, then you're going to write your command binom pdf npx. So notice how this is not CDF, it's PDF. And then I'm going to do our substitutions, binom PDF. So n is 3, p is 0.5, and x is 2. Remember, exactly 2. Okay, and then when you do this on the calculator, you're using, you don't need to do 1 minus. It's not a complement. So you have to stay alert. You're not doing 1 minus, but you're always going to do the second bars. And you're always going to do, it's distir, right? Distir. Second bars, distir for distribution. And then it's always alpha. But then you have to be careful here because there's the option A and the option B. The first one, the PDF, is the option A, and that would be the math option. Because the other one for CDF, it's option B, and that was the apps option. Okay. Okay, so when we do that calculator, second bars, alpha, math. Okay, so then you get this. So you get trials, and that's going to be 3. P, that's going to be 0.5. And then X value, that's going to be 2. And then it has pace. So trials 3.5, 2. And you should double check that you didn't put an error. Sometimes the errors that are made is that the students don't put they don't put the decimal. So be careful. And then you don't have to round this nearest thousands because this one already terminated on the thousand. So you actually don't have to do any rounding for this one. And I think I'm going to look for another calculator that I have around here because I think on some of the calculators, I think they don't always bring up trials, P and X value. I think they have to do commas. They have to do 3 comma like this, 3 comma 0.5 comma 2. So in a little bit, I'm going to just turn off my webcam for a little bit. I'm gonna go look for my other calculator because I think the other one does that. Just in case yours does that too, can show you that. But before I go look and show you, let me just show you the table here. So on this table, you see that you have to know your N. So you see they tell you that your N was 3 for the 3 coin tosses. And then you have to know your X also. See how your X is here under 2? And then you have to know your probability, which remember was 1/2. Oh, here it is, 1/2, 0.5. And then you follow that. So you follow this, follow that, and there it is. See, that matches what we got on the calculator. So I think if your system on your homework, if they asked you to do a table, that was you still have to set this up. You have to you have to know your N, you have to know your X and your P. So you still need to set that up. But then you don't have to do second bars and alpha if you don't use your calculator. Then you have to read your chart, but you have everything you need here, the N and the P and the X, and then you can find that on your table. Okay. Okay. So let me go check real quick for the other calculator so I can see if I can show you that. So let me just turn off my webcam for just a minute. Okay, class. So I was looking for my other TI-84, and I think I left that one in my office back in March when we had to leave on an emergency, right? We had to leave suddenly. And I think I left that other calculator in my office. I do have another TI-84 as a backup that I brought with me, but it doesn't do what I wanted to show you. So I thought I had that one with me, but nope, I think I left that in my office. So what it what happens, it's a TI-84 just like this, except the way it's programmed is that when the student types in the formula, the command, second binomial, and then their alpha math, it doesn't come up like this. It doesn't come up with trials, p, and x value. It comes up to where they have to type it in like this. They have to type in 3 comma, and I have to tell them that the comma is above the 7. So they have to type in the NPX, they have to type in 3 comma point 5 comma 2 and then hit enter. Whereas for us, we have this heading trials p x value, and we just type in 3.5 and 2 without commas. So I wanted to show you that. And then I don't know, like those of you, this is the first semester, like the first time we've ever allowed um, those phone apps, which I don't um, approve of, but that because of the need for the emergency, right? Because of the urgency, right? They said they would allow for the first time the phone apps, which you've never done before. I don't know on the phone apps. It might be that you might have to put 3 comma point 5 comma and 2. I don't know if this shows up on your phone app. So if it doesn't, then it might show up to where you have to type in 3 comma point 5 comma point and then 2. Okay, so just be aware of that. Okay, all right, so then moving on. Okay, now let's go to those extra problems from the worksheets. That if you didn't print that worksheet, you should do that now. So you should pause like the video and go get it, print it and get it. It's in your module. And it looks like, let me see. Let me see. Okay, so it looks like this. These are extra problems that I mostly got from the ebook mostly, I believe. So yeah, everything is somehow from an ebook for the most part, right? Okay, so here it says public opinion reported that 5% of Americans are afraid of being alone in a house at night. So you see there's a percentage that's given 5%. So that's your probability. So we're going to have here right here under probability, we're going to say 5%. And when you move your decimal over 2 places to the left, that is 0.05. Okay. And then it says that if a random sample of 20 Americans is selected, okay, that's your N, the number of trials, and the keyword is randomly, right? 20. Okay. Then find the probability that there are at most 3. So here's your vocabulary. I'm going to put that in yellow. At most 3 people in the sample who are afraid of being alone at night. Okay, so when I look that up on my sheet there, at most, let's see. Here we go, see, at most. So that's going to be this. Probably x is less than or equal to a given number. Okay, so we're going to say probably x is less than or equal, and the given number was 3, see? And then Binomial Cdf NPX. Okay, and then we start doing our substitutions. Binomial CDF, N is 20, P is 0.05, and then X is at most 3, so X is 3. And this one doesn't have any subtraction. There wasn't, it wasn't under, it wasn't under this column here where you have to do X minus 1. It wasn't under this column here. These are the only ones where you have to subtract X minus 1. Yours didn't, okay? And so what this means is, what are we finding? We're finding, and it's not a complement. So CDF start from 0. So you're finding P of 0 plus P of 1 plus P of 2 plus all the way to P of 3. That's what you're finding. Okay. So that means here, what you're finding, X equals the number of successes. It will be 0, 1, 2, 3. Okay. And yeah, and that makes sense. See, X is less than or equal to 3. Okay. Okay. So then you would use your calculator commands. So we're going to use second vars alpha and then the apps, option B. So second vars alpha and then right here purple apps B. And you want to just double check. Always see it says CDF, and that's what you want. And you didn't have to type in 1 minus. It wasn't a complement idea, okay? And then trials are 20. Probability is 0.05. And then the X value is 3. And just double check the numbers because sometimes people forget the decimal. And this is pretty close to 1. And if I round to near thousands, tens, hundreds, thousands. Is a neighbor 5 or more? Nope. Yeah. So, if you ever get a negative number, probably shouldn't be negative. If you ever get anything over 1, there's something wrong because probabilities are, remember, between 0 and 1 inclusive. Okay. So next, still related to the same problem. So you're probably still going to be 0.05 for this next problem. And your trials is still going to be 20. That's not going to change. But what changes is your vocabulary. There are a minimum, there's your vocabulary, minimum of 6 people in the sample who are afraid of being alone at night. So you want to go to your vocabulary and look up minimum. Oh, here it is, the very last one. See that? A minimum of, there it is. Okay, so you're going to write this. Probably X is greater than or equal to the given number. And the given number is 6. Okay, the complement, 1 minus binomial CDF in P, and you also need X minus 1. And then you're going to do your substitutions. 1 minus binomial CDF. N is 20. P is 0.05. And then X, remember, six people, minimum of six, 6 minus 1, which is 5. Okay, so, and this is a complement, so this is going to be 1 take away. And remember, CDF starts with 0. So it's taking away P of 0, taking away P of 1, taking away P of 2, taking away P of 3, taking away P of 4, all the way taking away P of 5. See, 1 minus binomial CDF, 6 minus 1 is 5. So you're taking away all of these. And then what are you left with? What are you finding? That means you're finding P of 6 plus P of 7 plus P of 8. How far do you keep going? All the way. See, there's 20. So you don't want to write all those out. So do dot, dot, dot plus, if you want, you can do P of 19, but then for sure P of 20. You don't want to put all of those in there, but you need to write this correctly, dot, 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 all the way to P of 20. And that's what you're finding, okay? So when you use your calculator, you're going to have to use 1 minus, and then second bars, and then alpha, and you want the PDF. So that's going to be the apps, option B. Okay, so turn this thing on, clear this. Okay, so remember, 1 takeaway, you can't forget that. Second vars, alpha apps. Okay, and then the trials are still 20, probably still 0.05. But now your x value here, remember 6 minus 1 was 5. So you want to put 5 in here, okay? So you're doing 1 minus from P of 0 all the way to P of 5, okay? And then enter, double check that, enter. And this is a really small number. Oh, and then the other thing is also, once you have this, what you're finding, now you know number of successes is you want, this is 6, 7, 8, all the way to 19 and 20. That's what you're finding, okay? And it makes sense here. See, greater than or equal to 6. See? All right. Okay, so then this is 3.292924325 e to the negative 4. What that means is that's 3.29294324 times 10 to the negative 4. This is a small number. If it were 10 to the 4, that'd be a 1 with 4 zeros behind it. So that'd be 10,000. It'd be a big number. And a big number makes the number bigger. But this is a small number because the next exponent, this, you're going to move your decimal left. Because if you move it left, here's your decimal. If you move it right, you make it big. You want to make it big. You want this is a small number. When you multiply it times this makes it small. So the only way to move it to small, make it small, is move left. So this is just being formal here. And I'm going to add 3 zeros. And then this 3 counts as a move. So there's like your 4 moves, right? 1, 2, 3, 4. But you don't forget about all these. Those get tacked on. And then you round to nearest thousands, tens, hundreds, thousands. And the thing is that when you look at the number to the right, is that 5 or more? No. So actually don't round to the thousands to avoid 0. They don't, because this isn't 5 or more, so you have 0.000, But in statistics, they don't like you to record 0 unless it's exactly 0. And it's not exactly 0. It's just a really, really small number. So we're actually going to have to round to the tens, hundred thousands, 10,000s instead to avoid an answer of 0. So if I round to nearest 10,000s, tens, hundred thousands, 10,000s. Okay, now look at this neighbor. Is that 5 or more? No. Okay, so the 3 will remain. So then I have 0.0003 tens, hundred thousands, 10,000s. Is this 5 or more? No. So okay, so I have that. And now I'm not recording a 0. Okay. Okay. So we saw some of that in the chapter 4. You should have observed that in your homework when you did the chapter 4 tests, the chapter 4 homework. You should have, like, you've seen this. Hopefully you should remember and see that. We've seen that before from the previous chapter. Okay, now there's one more page of extra problems, and then we can do the last part, the last idea. Okay, so this is let's see. Okay, so here it says that a coin is tossed 6 times. All right, so then that would be your number of trials. So 6 tosses. Find the probability, this got chopped off, of getting exactly 2 heads. Okay, so on your number of successes, it's 2 exactly. And the idea of the heads, remember we saw heads over heads or tails. Remember we saw that earlier? So that's 1 over 2 heads or tails. And 1 divided by 2 is just 0.5. So we saw that earlier, okay? And the vocabulary is exactly 2. Okay, so remember right here, exactly, probably x equals 2. Equals, and then you want to write down the formula Binomial PDF in px. Okay, now you're going to do the substitutions. Binomial PDF. N is 6 tosses. P is 0.5 from the 1/2. And x is 2 from the exactly 2. And what you're finding is you're just finding P of 2. So see right here we have exactly 2, okay? And then when you use your calculator, you're going to use second vars alpha, and then you want the math because that's option A. Okay, so second vars alpha math, and you see how you see PDF there. Okay, so your trials are 6. Your P is 0.5. And then your X value is 2. And just double check that. Sometimes people forget the decimal. So you have 0.2 2, 3, 4, 3, 7, 5, tens, hundreds, thousands. Look at the number to the right. Is that 5 or more? Nope. So 0.234. Okay. Okay, a student takes a 15 question multiple choice exam. Okay. So for this one, 15 question, that's your trials in trials. It has to do with your questions on the test. With 5 choices. Okay, so your probability is, when you think of successes, right? You're going to have one correct answer, right? That's the idea, that you make a test with one correct answer over 5 choices. So this is successes over the total. And you have 5 choices. So maybe it's like, A, B, C, D, E on those multiple choice tests, maybe. So you'd have 1 divided by 5. And 1 divided by 5 is 0.2 on your calculator. Okay, 0.2. Okay. And find the probability of guessing exactly 6 out of the 15. Okay, so it's exactly 6. So it's 6 exactly. Okay, so again on the exactly, here we are. X is equal to probably X equals 6, binomial PDF in PX. Let's do your substitutions. Binomial PDF, N is 15, P is 0.2, and X is 6, exactly 6. So again, that uses second second vars. Alpha math. Okay. There's no 1 minus, it's not a complement. So it's just second vars alpha, and you want the math, option A. Just double check that. See PDF, double check that. Okay, so trials here are 15, probably is 0.2, and then X value is exactly 6. Get that. Tens, hundreds, thousands. Okay, look at the number to the right. Is that 5 or more? Yep, it's a 9. So add 1 to that. Okay, now these last 2 problems, our committee, like we decided not to include these on the tests, or like on the final, these last 2, but they are going to be on your homework. There's a couple of them on your homework. And so I'm going to show you these. And these, you just have to be careful on these. They can be a little bit tricky because they give you like a certain probability related to a group or like a subject, but then they come around and they ask for the probability of like the opposite of that subject. And that's why you have to be careful. So you can work this out, these kind of problems, you can work them out two ways. And you'll probably gravitate to one over the other, depending if you like left brain, right brain. And I'll show you both of them. So the first thing says that approximately 10.3% of American high school students drop out of school before graduation. So you notice how they're talking about the dropouts. So if I focus on that, um, let me see. But I want to focus actually, if I keep reading, it says choose 10 students entering high school at random and then find the probability that right here at least 6 graduate. Okay, so notice how this probability is talking about um, dropouts, but then they don't ask you about the probability of dropouts. They ask you for the probability of those who graduate. So that's why you have to be careful here. So that's why if I focus on this problem, I focus on the graduates here. Here, the probability for the graduation rate is you start off with a total is 100% minus the 10.3%, which is that dropout rate. And on your calculator, when you do 100% minus 10.3%, that gives you 89.7%. And and then you move your decimal over 2 places to the left, and that gives you 0.897. Now, n is still the same. N is still 10. So choose 10 students. And you're doing that randomly. Okay. Excuse me. So let me look at the vocabulary. At least 6. So go to my vocabulary. See right here. At least. And see this here. So probably x is greater than or equal to 6 is equal to, and here's the formula. It says complement 1 minus binomial CDF in P, and then you need another x minus 1. Okay, so I do my substitutions. This is 1 minus binomial CDF. So n is 10. P is 0.897. And then this is 6 minus 1, which is 5. Okay. Okay, so then what that means is you're doing 1 take away P of 0, take away P of 1, take away P of 2, take away P of 3, take away P of 4, take away P of 5. And then that means that what you're finding P of 6 plus P of 7 plus P of 8 plus P of 9 all the way to P of 10, because see, there was 10 students chosen. Okay. Okay, so when you write that down, so when you type that in your calculator, you have to remember to do 1 minus. So 1 minus second vars, and then alpha, and then you want to do apps, right? Because it's a CDF. Okay, so you see 1 take away the CDF, make sure that's correct. Okay, and then your N is 10, and your probability is 0.897, because that focuses on the graduation rate, right? And then this is 5. Okay, because 6 minus 1 is 5. Then enter, enter. And then you would round that to nearest thousands. So that'd be 0.998. Okay. .998. Okay. All right. Okay. And oh, and don't forget here in the X, what you're finding P of 6. So this is 6, 7, 8, 9, all the way to 10. So you see X was greater than or equal to 6. 6, 7, 8, 9, 10. Okay, class. So now I do this problem again, but doing it with the perspective for dropout rates, because see, this was focusing on the graduation rate. What if you want to focus on this dropout rate? So let's do that. So the dropout rate is 10.3%. And when you move the decimal to the left, 0.103. And your N is still going to be 10 trials. That's not going to change. And here to help you with what X is, if you're focusing on the dropout rate, see, let's say that because it said at least 6 graduate, right? So let's say if 6 graduates, then how many dropouts do you have? Well, you would have 4 dropouts, right? Because there's a total of 10 students. So 6 graduate, 4 drop out. If 7 graduate, then 3 drop out. If 8 graduate, because there's a total of 10 kids, 10 minus 2 is 10 minus 8 is 2. So this is 10 minus 7, 10 minus 8, 10 minus 9, and 10 minus 10. Okay, so if 9 people graduate, then you only have 1 dropout. And if all 10 graduate, which is really awesome, everybody graduates, 100% passing rate, then you have 0 dropouts. So we're focusing on the dropout. So here your dropouts would be 0, 1, 2, 3, 4. So I don't I don't really have a vocabulary for that. I mean, um, I guess if you say like, what's the complement of at least six or more, what's the complement of six or more, then it would be below that. So I guess you could put less, I guess you could put less than or equal to, I guess you could do this, x less than or equal to 4. Okay. But, binomial CDFs, binom CDFs, right? In PX. Okay. So binom CDF, N is 10, P is 0.103, and X, right? It's X is going to be 4. Because remember, CDFs start from 0 all the way to 4. Okay. And so I guess you could use that. So it's not like it's not like I mean, I guess you're doing less than or equal to, right? In PX here. So I guess that's like thinking what's the complement of at least 6? At least 6 or more would be, could say it's less than or equal to 4, then I guess you could say something to that effect. But when we find the binomial CDF for this, it's going to be the same as this. So when I do second vars alpha, and I want to do CDF, which is the apps, see, CDF, and the trials are still 10, but this time the probability is 0.103, and then X, as we said, was 4. And we should get the same thing that we got over here, 0.998. See, so we get the same thing. I didn't write down that long decimal because I didn't have any room on the other side. I guess I can write it down here. Then you round to your 1,000. And is the neighbor 5 or more? The neighbor 5 or more? No. So you see how we got the same answer? So this one's doing it, the probabilities with the focusing on the graduation rate. This one, the probability is focusing on the dropout rate. So the probabilities are a little bit different. The ends are still 10 trials, but then also your X's are a little bit different here because this is going 6 through 10. This one's 0 through 4. Okay. But we end up with the same answers. Okay. And that's because the P, the probabilities had a different perspective. Okay. Okay, we're gonna do one more like that using the same high school problem, but now they say that find the probability that all 10 stay in school and they graduate. Okay, so we keep this side the same as far as the graduation rate. P equals graduation rate, which is 0.897. So I'm going to just grab that from here. 100% minus 10.3%, which is 89.7%. Move my decimal over 2 places to the left. And my N is still 10, right? 10 students in our trial here. Randomly 10 students. Okay, and then here your X is graduation. All 10 of them all 10 stay in school and all 10 of them graduate, which is really awesome. So here, this is an example of 10 exactly. All 10 of them graduate. So remember with exactly, here we have this, see? PDF. So probably x is equal to 10, all 10 graduate. Binomial CDF in PX. And this 10 probably is 0.897 and x is 10. Okay, so I use my calculator. Second bars, alpha, and then you want the apps, and then, and it's double check CDF, okay. So trials, okay, 10 probably is 0.897, and then x value is 10. And then we get, I was supposed to get 0.337. Did you get 0.337? Let me see what I do wrong. Oh, I know. I didn't make it. I know I didn't make it a PDF. It's exactly. Yeah, that's what happened. It's exactly. Yeah. So exactly is PDF. So you have to be careful. Those are common human errors. I'm getting tired, right? Because I'm almost done. I'm getting tired. So I hope I don't fall asleep. Sorry if I think on some videos, yeah, I might fall asleep. I always catch it and fix my mistakes. I was just sorry. This is hard to take myself over by myself here. I need like the actual class, even if it's the remote learning class, to keep me awake. So sorry. I hope I don't have to redo those videos. You just send me an email, let me know if there's a video I need to redo. Or are you okay? Are you able to capture the material? All right, let's see. Sorry about that. Okay, so this is exactly, so this is a PDF. Okay, so try one more time. Second bars, second bars, alpha, and then we want math because it's the PDF. Trials are 10. P is 0.897, and then 10. Okay, that's more like it. More like it. 0.3372286624. And I round that to the nearest thousands, tens, hundreds, thousands. Okay, look at the number to the right. Is that 5 or more? Nope. 0.337. All right. Okay, now we're going to do this problem again and we're going to get the same answer, but now we're going to do it from the perspective of the dropout rate. So this is going to be looking at the dropout rate, and they tell us that it's 10.3%, so that's 0.103. And N still going to, we're still randomly working with 10 students. Okay, but now let's see what our X is going to be. So if all 10 of them stay in school and they graduate, then doesn't that mean that you don't have any dropouts? Doesn't that mean that X is equal to 0 dropouts? Because this 10 over here was 10 exactly graduates. But when you focus on the dropouts, if all 10 of them stay in school and graduate, then you have 0 dropouts. And this isn't exactly. So this is going to be px equals to 0. Binomial PDF in px. And so remember on your test, this I want to see this. I want to see the formula, like the command, and then the substitutions. N is 10, P is 0.103, and X is 0. Yeah, I want to see that. So you want the full credit on the test, you have to set up the probability, and then the command, the substitutions. Oh, and then what are you finding? So we're finding here, starts with 0. So you're just finding P of 0. And I might have to go back. I might have to go back and I think I might have to go back and put what I'm finding for the previous problems. I think I didn't do that. I'll go back in a little bit and see. Okay, but this is just P of 0. So then we're going to do second vars alpha math 10, and this is probability is 0.103, and then X was 0. And then enter. And we should get the same thing, see, as we got on the other side. And when you round that to the thousands, tens, hundreds, thousands. Look at the number to the right. Is that 5 or more? Nope, it's a 2. Okay, so this part I was talking about what are your findings. So here we're finding PDF, we're finding P of 10. So this one I needed to squeeze in here, P of 10. And over here, I did tell you what we were finding over here. 6, 7, yeah, we did that. Over here, to CDF. So here we're finding P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4. So P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4, because this starts with 0 all the way to 4. So you want it here. Okay. And then I think this one, it's a PDF. So this one's just P of 6. And this one I did put that. Yeah. Okay. So I want you to write it up that way. And I'll take a look at the answer key for the test, because I mean the practice test. I may not have that listed like that, so I might have to look at my practice test answer key. And of course I do the Zoom test review as well. So I'll do that, but okay. All right. All right. So that concludes that part. Okay, now there is one other page that we need to do. It's also part of this 5.3, and we'll be done. We're almost done. I think we're down to 2 more pages. So this is one that has, I think, 2 examples on it, this page. And then there's one from your workbook that has 1 problem on there. And then we'll be done. Okay, so this is also in chapter 5.3, and it says here that the mean, the variance, and the standard deviation of a variable that has the binomial distribution can be found by using these formulas. So we're actually going to use these formulas. Yeah, we're not going to use a calculator command. We're actually going to use these formulas. So we are going to apply these, okay? So, and these are still examples of binomial distribution problems, but what are we finding? We're not finding a probability. We're finding the mean, the variance, and the standard deviation. And you do have to have these formulas next to your problems. And remember, I was telling you about Q. A lot of times people miss this because they don't write down Q. You want to make sure that Q, remember what we said the value of Q was? Q is the value 1 minus P. So a lot of times people miss this because they don't write that down. So Q, like right here, Q is the value 1 minus P. So really this is N times P times Q, and Q is 1 minus P. Same thing here, N times P. Oh no, that's fine. That's Q. I'm sorry. This is fine. This is P. It's Q. So this one has a Q. This one doesn't have a Q. This one has a Q. This one has a Q also. So this is square root of N times P, and Q is 1 minus P. Okay? So you should add on to the formula because a lot of times people miss that. They don't remember what the value of Q is. Okay, so let's see what the problem, let's see what that looks like. Let me see. Okay, so likelihood of twins. Okay, so the statistical bulletin published by Metropolitan Life Insurance Company reported that 2% of all American births result in twins. Okay, so that I'm going to still do N, and I'm still going to do P, but I'm not going to do X here. I'm not going to do X. See, there's no X. We're not finding the probabilities. We're finding mean, variance, and standard deviation. So that's why I'm not going to have the X here. You see in the formulas, there's no X. So, but I could though, I could do Q so that we won't make that mistake. So I could put Q, and P is the percentage. So this is 2%. That's going to be your probability. And you move it over 2 places to the left. That's 0.02. You know, the other thing you could do, I don't think I mentioned this, but the other thing you can do is percent means parts per 100. So the other thing you can do is say 2% is 2 over 100. And then when you divide 2 divided by 100, that does give you 0.02. Because sometimes people forget, like, how did she say to move? Did she say move 2 to the left or 2 to the right? Sometimes you forget. What did she say to move, left or right? So another way is no, percent means parts per 100. So if you divide 2 divided by 100, that will give you 0.02. If a random sample of, wow, 8,000 births. Okay, there's your keyword, random sample. So it's 8,000 births. So those are your trials. And the keyword is random, right? Find the mean, find the variance, and find the standard deviation. Okay. So even though they don't um, have Q listed here, you're going to need it in the formula. So you could use that right now. Here, Q, remember Q is 1 minus P. You have to remember that. And so this is 1 minus 2%. Well, actually, And well, you need to have the same units. So actually, I'm going to say 1 minus 0.02 because I can't, I need the same units. This is a percentage, this is a counting number. So I'm going to do 1 minus 0.02. And 1 minus 0.02 is 1 minus 0.02 is 0.98. Okay, and then that way we're ready to go. So now when we find mean, which is mu, you're not going to put x bar. Remember, you're going to use mu, and that's n times p. So n was 8,000 and p was 0.02. So when you do 8,000 times 0.02, that gives you 160. Okay. And this is, twin bursts. So we would, put our units in there, but this is not really a unit. This is like twin bursts. So it'd be fine. I'm not going to put that in there. Then variance, if you want to put in that same order. Let's see. Let me see. So, okay, so they use sigma squared, or you can use sigma sub x squared, right? I think that's what your calculator uses also. Okay, and then that's equal to n times p times q, which is equal to n times p. Well, let's see. We already found q. So since I already put q over here, then I can just say n, which is 8,000 times p, which is 0.02 times q, which I already did this on the side here, so I can just say 0.98. Okay, so then I have 8,000 times 0.02 times 0.98. That looks like 156.8 twin bursts. Okay. Okay, and I'm running out of room, so I'm going to put the other one over here at the top. So the other one right here. Because I'm running out of room. The other one was standard deviation. Okay, so they have that sigma, or you can say sigma sub x, right? And they say that's the square root of NPQ. So you can do this. We already know from over here, you already know NPQ. NPQ was 8,000 times 0.02 times 0.98, which is 156.8. Okay. So let me see, I'll go ahead and do this. 8,000 times 0.02 times 0.98. And you already know that that was 156.8. And you don't want to have any round off error. If you didn't have to round off here, it wasn't really, really long, where decimals, long string of decimals, we have to round off. So we didn't have to round off. But if you did, you don't want to use the round off. You don't want to have round off error. Go with the exact. Okay, but this is fine. And on your calculator, you want to use the second button. and the X squared button, because on top of the X squared button is the square root key. So you want to do second, second, and then this one right here, this X squared button, because on top of that is the radical. And you want to type 156.8 and then hit enter. And that gives you 12.5 to 198067. And then if I round that off to the nearest tenths is what I have here. If you look at the neighbor to the right, is that 5 or more? No. So that's about 12.5. Yeah, so as far as these rounding, because it's mean, and variance and standard deviation, remember they said, so these, they're not like the probability distributions where you round those to thousands. This is mean, standard deviation, variance. You round one decimal place beyond how your data is given. So here, your data would have been given like as county numbers, because these are number of births, right? 8,000 births, and they're either a boy or a girl, right? So these births, so they're like county numbers. So if you round one decimal place beyond a county number, that's tenths place. So that's why I'm rounding to the tenths place. But the Connect Math, or your system, is real good about telling you what to round off to. Your system is real good about that. Okay. All right. One last page and then we'll be done with this section, which again is mean, mean, variance, and standard deviation. So this one, okay. So this, I have two problems. This one I got from your ebook, and this one's a good one. Okay. So let's see. So it says that the mean and the variance and the standard deviation for a binomial variable can be found by using your formulas in section 5.2. However, shorter but mathematically equivalent formulas for the mean, variance, and standard deviation are used. So we'll take them. We'll take them. So you saw this in your workbook. Mu is n times p. Variance is sigma squared, n times p times q. Standard deviation is sigma square root of npq. And again, you just have to, they don't tell you the value of q, but I have it here. You have to remember q is the value 1 minus p. So you have to remember that. Okay, so here's another example. This is an example of another binomial distribution problem, but we're not going to find the probability. We're finding the mean and the variance and the standard deviation. And these are just so we can check our work. I left the answers there, and you can see how they rounded those. See to the nearest 10. See that nearest tenths? Okay, so household wood burning, and American Energy Review reported that 27% of American households burn wood. Okay, so they probably have like a fireplace, maybe, and that's why they do that. If So we built our home, and we had a fireplace, but since we live in Texas and San Antonio, we actually took that out of the plans and had like a more like an entertainment area set up for the television and set. So yeah, we opted out of the fireplace option. But 27% American households burn wood. If a random sample of 500 American households is selected, find the mean, the variance, and the standard deviation of the number of households that burn wood. Okay, so it would be like you know, yes or no. Do you burn wood? Yes or no, right? Um, and so um, um, the percentage is 27%, and you move your decimal 2 places to the left. Or remember, we said percent is parts per 100. So if you do 27 divided by 100 and you type that in on your calculator, it's 0.27. Okay. All right. Okay. So then N is 500 trials here. So these are your households. And then Q is 1 minus P. So it's 1 minus 27%, which is, you have to have the same units, 1 minus 0.27. So 1 minus 0.27 is 0.73. Okay, find the mean. Okay, so mu is N, which was, remember, 500. So what you should do really is also, like right now, you should turn off the video, like stop it, stop your video, and then do this on your own, and then turn on the video and then check your work. Okay, so y'all should do that. And I don't think I mentioned that in the other problems today, so sometimes I forget to mention everything. But like that's what you should train yourself to do once your teacher does. I like today I did a lot of PDFs, a lot of CDFs. I did more than one complement. So when your teacher does one that's brand new, you do that with the teacher, but then once you say, oh, that looks like she's going to do another PDF, then you should really stop the video and then try it yourself and then turn it back on and watch it. Okay. So I don't always bring that out, but I don't always remember to call that out, but you should practice that and get into the habit of doing that. Okay. Okay. So turn off your video, and then when you come back, then we'll check your work. Okay. Okay. So I'm assuming you turn off your video, you have all your work, and now we're going to check it. Okay. So mu is N, which is 500 times P, which is 0.27. And when you multiply 500 times 0.27, you should get 135. Okay. Variance is N times P times Q. So N is 500, P is 0.27, and Q is 0.73. And when you multiply 500 times 0.27 times 0.73, that should give you 98.55. And then when we round this to the nearest tens, because one decimal place beyond how your data is given, so we're assuming our data is given as like county numbers. So you're reporting, right, how many households, right? How many households burn wood. So that's that you're reporting, oh, it was 1 or 2 or 3 or 4, like how many out of the 500. So that's county number. Look at the number to the right, add 5 or more. Yep. So add 1 to that. You have 98.6. And then your standard deviation, sigma is equal to the square root. And then I put here sigma squared here, whereas in your workbook, they just put NPQ, square root of NPQ. But you see that NPQ is sigma squared. So that's fine. So you can put You want to be consistent. It's NPQ. And this is the square root of n, which is 500, times p, which is 0.27, times q, which is 0.73. So when you multiply 500 times 0.27 times 0.73, well, remember we did that over here? 500 times 0.27 times 0.73. So you want to put this. You don't want to put the round off error, because then you're going to have a round off error again once you round that off. You want to put this exact 98.55. And when you take the square root of that, it's the second button and then the x squared key, because the x squared key has a radical on that. So you do second square root and then 98.55 and then hit enter. That's about 9 point something. 9.927235265. And then when you round that to the nearest tens, you look at the number to the right. Is that 5 or more? Nope. So it's about 9.9. Okay, and then the last problem for this section. A university has 20,000 students, of which 75% are male, or excuse me, 75% are female and 25% are male. If a class of 40 students is chosen at random from the university population, then find the mean and the variance. Okay, so that not the standard deviation, just the mean and variance of the number of female students. So this is an interesting problem because you have two percentages, so you just want to stay alert. They're asking for the mean and variance of the number of female students. So when you look at P, you want the probability for the female students, which is the 75%. So you want to be careful there because people can make a mistake right there and they might use the 25%, but that's for the male. And you also want to be careful with the N because it does tell you the university has 20,000 students, but then it also says that they're not going to choose like 20,000, that's too many. They're going to choose 40 students at random. So that keyword random really comes in handy, and the N is going to be 40 students randomly chosen. And then Q is equal to 1 minus P. So 1 minus P is 75%. That was your P for the, we're focusing on the females, not the males. And that you need the same units. So that's 1 minus 0.75 because you have to move your decimal over 2 places to the left. And then on your calculator, when you do 1 minus 0.75, that just gives you 0.25. So now your mean is your mu. Don't use X bar like chapter 3. Use mu here for these. So mu is n, which is 40, times probability, which was 0.75. And 40 times 0.75 should give you 30. You double check that on your calculator. Okay, and then this one, variance. Okay, unit squared for variance. So n is 40. P is 0.75. Q is 0.25. So when you multiply 40 times 0.75 times 0.25, you should get 7.5 on your calculator for that. Okay. And this would be normally like units squared, but we don't have like units like inches, or we don't have a form of units on here as far as dimension like units or kilometers or what have you. So this is fine. We're not going to like and I think on one of the other problems we had cents on one of your tests. You had cents squared, right? Cents squared. This one we don't have any units given, measurement or so we will just leave it at 7.5. Okay, we won't have to put like female squared. We won't do that because of that. Okay, it's not a unit. All right. Okay, so good luck with your finishing your homework then. Okay, take care.